There's a heavy emphasis on understanding number theory for the Florida Math League contest. I placed 6 of the problems from the 2016-2017 contest into this category, but really I could have placed several more. They just fell better into other categories. But you need to understand factors, multiples, prime numbers, least common multiple, greatest common factor, and all of the efficient methods related to solving problems of that type. I may have this problem number 4 may have been better placed in the use the answer choices category, because if we're trying to find the greatest common factor of 49 and 50, sure, I could do I could break them down into their prime factorization and sort them into a Venn diagram, find the GCF, but it's a lot easier to use the answer choices, because the greatest common factor of 49 and 50 must be a factor of both 49 and 50. That's where the word common comes from. And 1 is certainly a factor of both 49 and 50, because 1 is a factor of every number. 7 is a factor of 49, but not a factor of 50. 49 is a factor of 49, but not 50. And 2,450 is not a factor of either of them. It's likely a multiple of one or the other, or more than likely both. It's probably the LCM. So the only correct answer choice here is 1. If you took the time to do it to find all the factors, which, in this case wouldn't take long, it'd be 1, 49, and 7 for 49. And for 50 it would be 1, 50, 2, 25, 3, 4, 5, and 10, 6, 8. That's it. So they have no common factors other than 1. But again, I wouldn't go to all this trouble, or I wouldn't find prime factorization and use a Venn diagram. I would just use the answer choices for a problem like this. Problem number 8. Ike likes a number only if the sum of the digits is 9. How many integers between 10 and 100 does Ike like? In order to solve this problem, you really need to, as soon as you read this phrase, the sum of its digits is 9, you have to recognize that that is the divisibility rule for multiples of 9. If a number is divisible by 9, the sum of its digits is some multiple of 9. So, wait a minute. Yeah, if a number is divisible by 9, the sum of its digits is 9 or some multiple of 9. The reason I hesitated there is because this doesn't say any multiple of 9, it says 9 specifically. So we'll have to consider that carefully. But basically I don't need to check very many numbers, I just need to check any multiples of 9 between 10 and 100. So the first multiple of 9 greater than 10 is 18. Get a better color here. 18, 27, 36, 45, 54, 63, 72, 81, 90, 99. Interesting, because I hadn't considered, that's why I got that problem wrong actually. I got this problem wrong when I first did it, and the reason is I saw divisibility rule for 9, and I didn't see that it was specifically the sum of the digits is 9, not just a multiple of 9. The sum of these digits for 99 is 18, so that would not be included. But all of these other ones, you could tell very quickly, have a 9 as the sum of their digits. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. Well, now that I count them, I don't see how anyone could include 99, because you'd have to count 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the answer choice should be D. The answer choice is D. I didn't miss that one after all. I was thinking of different problem. I missed 4 out of the 35 on this one because I was rushing and I didn't take the little bit of extra time I had at the end to check my work. So learn a lesson from that. Problem number 9. Which of the following is a multiple of 75? The key to answering this question is, well, I take it back. I think again we're looking at answer choices because none of these are very large numbers. So I can list multiples of 75 faster than I can come up with any clever way to eliminate some of these answer choices, because 75, 150, 225, 300, 375, right away I find B. I would keep going, however, I mean, we can see that 275 is not going to work, but just to be on the safe side, 375, 450, 525, okay, that's not one of them, 600, okay, I would try to, if it's that quick to do, I would take the bit of extra time to do the next few, just to make sure you don't get two that seem like they could be the answer, because if that happens, you know one of them can't be, and you made a mistake. But you really have to use your time wisely on a timed contest like this. Number 10, how many two-digit integers are prime and have a ones digit of 1? I think I'm going to list, there aren't all that many two-digit integers with a ones digit of 1. So I think I'll just list them. There's 11, there's 21, 31, 41, 51, 61, 71, 81, 91. I know 11 is prime, so that's one of them. 21 is not prime, 3 multiplied by 7. 31 is prime. 41 is prime. If you weren't sure about either of these, you only need to check up to a number that if you multiply by itself would be greater than the number. So I know it's not a multiple of 2. It's not a multiple of 3. 3 plus 1 is 4. That's not a multiple of 3. It's not a multiple of 4 because it's not a multiple of 2. It's not a multiple of 5 because it doesn't end in 0 or 5. If it's not a multiple of 2 or 3, it can't be a multiple of 6. And I can stop checking because 6 times 6 is 36. For 41, it's not a multiple of 2 or 3 because 4 plus 1 is 5. If it's not a multiple of 2, I don't need to check any even numbers. It's not a multiple of 5, clearly. I don't have to check 6. I have to think about 7, but 7 times 7 is 49. And this is 8 less than, well, 7 times 6 is 42. This is 1 less than that, so it can't be 7. And I'm done checking there. 5 plus 1 is 6, so this is a multiple of 3 and just a multiple of 3. 3 times 17, so I rule that one out. That's not prime. 61 looks prime. It's not a multiple of 2. 6 plus 1 is 7, so it's not a multiple of 3. I don't have to check 4. It's not a multiple of 5. I don't have to check 6. 7 multiplied by 9 is 63, and this is 2 less than that, so it's not a multiple of 7. I don't have to check 8. It's not a multiple of 9 because 6 plus 1 is 7, and 9 times 9 is 81, so I don't need to check anymore, so that one is prime. 71, 7 plus 1 is 8, so it's not a multiple of 2 or 3. Or I don't have to check 4. It's not a multiple of 5. I don't have to check 6. 7 times 10 is 70. It's one more than that, so it's not a multiple of 7. I don't have to check 8. It's not a multiple of 9 because 7 plus 1 is 8. And 9 times 9 is 81, so I don't need to check anymore. 9 times 9 is 81, so 81 is not prime. 91, it's not a multiple of 2. This is a tricky one. This is the one that'll get you. It looks prime, and if you're rushing, you won't realize that it's composite. It's not a multiple of 2. It's not a multiple of 3 because 9 plus 1 is 10. I don't have to check any other even numbers if it's not a multiple of 2. It's not a multiple of 5 because it doesn't end in 0 or 5. I don't have to check 6. Is it a multiple of 7? Yes, 13 sevens. So that's the one that people will miss if they're going too fast. So 1, 2, 3, 4, 5, 6. A lot of people will answer choice A, and it should be answer choice B. In fact, why do I feel like I made a mistake? I should have, oh, it's right here. What am I doing? Well, they say 10 is A. What did I miss? 11, 31, 41, 61, 71. I'm sure you saw what I did. I said how tricky 91 was. I proved it was composite, and then I circled it. It's composite, so it's not included. We just want the prime ones. So 1, 2, 3, 4, 5. Answer choice A. Okay. Which of the following is a prime number? 3 plus 1 plus 0 plus 2 is 6. So that's divisible by 3. So that's divisible by 3, so it's not prime. This ends in a 5, not prime. 9 plus 1 is 10, plus 2 more is 12. That's a multiple of 3, not prime. 2017 is prime. If you're going to take a Florida Math League contest in 2017, you definitely want to know whether 2017 is a prime number, which means you also want to know about 2018 for this year. And I never look at I purposely don't pick up the contest until the day after, until after school, the day before the contest is given. So our department chair has the contest, but I haven't seen it when I'm making this video. I just know that from seeing these Florida Math League contests that 2018 is going to pop up on this thing. So we should know the prime factorization of 2018. It's 2 multiplied by 1009. So is that it? Is it a semi-prime, or is there more to it? We have to think about whether 1009 is prime. 1 plus 9 is 10, so it's not a multiple of 3. It's clearly not divisible by 2, so it's not divisible by 3. I don't have to check any other even numbers. It's not divisible by 5 because it doesn't end in 0 or 5. I don't have to check 6. I have to check 7. Uh, 4, 28, 29, so no. I don't have to check 8. 9 plus 1 is 10, so it's not a multiple of 9, not a multiple of 10. I should check 11. I can check 11 using the alternating digits. 1 plus 0 is 1, 0 plus 9 is 9, 9 minus 1 is 8, that's not a multiple of 11. I don't have to check 12, I do have to check 13. 1009 divided by 13. 7 13s is 91. That leaves me with 99, so that's not going to be a multiple of 13. I don't need to check 14 or 15 or 16. I do have to check 17. 17, 5, 50, 85. 5 17s is 85. What's that going to be? 8, 9, 153. 9 17s is 63, and 90 is 153. So that's not going to be, 17 doesn't work. How far do I have to go? I have to go pretty far because I have to check all the primes up to about 30 to really be sure. Really 31, because 31 times 31 is 930. I thought I could do that in my head. 31 times 31. It's 31 and 930, so 961. If I check all the way up to 31, I'm good, but you don't want to have to do that on the test. 1009 is prime. Okay? Know that. Know that the prime decomposition of 2018 is 2 times 1009. And you'll save yourself a lot of time if that question comes up. Let's see. Problem number, Google it, is 1009 prime. Yeah, that's another way to do it. You can't do that on the contest though. How many positive integers less than 100 have exactly 3 factors? Here's something you need to know. The only numbers that have exactly 3 factors are perfect squares, like 49 we did before. It's 1 multiplied by 49 and 7 multiplied by 7. So if you're going to list those factors, it would be 1, 7, and 49. Everything other than a perfect square is going to have factor pairs, and any multiple of 2 is an even number. So the way to have 3 factors is to be a perfect square. So you think about the perfect square is less than 100. That's a much easier question to answer. The perfect squares less than 100 are 1, 4, 9, 1 squared, 2 squared, 3 squared, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, so we don't need that. There's something tricky here though. How many factors does 1 have? Only 1. How many factors does 4 have? Starting with 4, we have 3 factors. 9 has 3 factors. This is trickier than I thought. Okay, perfect squares will have an odd number of factors, but they won't all have exactly 3. 4 does. 9 does. 16 does not, because with 16 you're going to have all this 2 times 8 and 4 times 4. That is 5. 25 has 3. So of my choices 1, 2, 3, and 4, it's either going to be 3 or 4 here. 36 doesn't. 49 does. We just did it up here. So it must be 4. Well, it was harder than I realized. You have to be careful. That's what's tricky about this test. Answer choice A. And I'm just going to double check myself on each one so I don't make I almost made a mistake on one of the ones on this video, so I want to be thorough. Okay, that was a long one, but as I said, number theory, understanding factors, multiples, and prime numbers is really key to this contest.